You delete 10 million rows from the swipes table. The delete succeeds. Then you check storage and it's gone up. That's not a bug, a misconfiguration, or a billing error. It's the single most important thing to understand about Iceberg, and once you see why, almost everything else it can do follows from it. Here's why. In Iceberg, a delete never removes anything. It can't. A Parquet file is immutable. You cannot reach in and take a row out. And the metadata layer from video 1 only ever grows. Every write adds a snapshot rather than modifying one. So a delete is not a removal. It's an addition. You add something that describes rows as no longer counting, and the pointer moves to a new snapshot where they don't appear. There are two ways to do that addition, and the choice is a genuine trade-off. Copy on write writes fresh copies of every affected data file with the deleted rows left out. The old files stay exactly where they are because older snapshots still reference them. Delete 10 million rows scattered across our table, and you might write 50 gigabytes of new files, while the 50 gigabytes of originals remain. Writes are expensive. Reads afterwards are as fast as ever because the current files are clean. Merge on read writes nothing but a small delete file recording which rows in which files no longer count. The data files are untouched. Any query reading them afterwards also reads the delete file and filters those rows out on the way past. That 50 gigabyte rewrite becomes a few kilobytes. Either way, storage grew. Nothing was reclaimed. Frequent small deletes on a rarely queried table want merge on read. Occasional deletes on a heavily queried table want copy on write because every accumulated delete file makes every future read do more work. Now, that sounds like pure cost. It isn't, because 3 of Iceberg's best capabilities are the same fact viewed from different angles. 1. You can undo a bad job. A job runs with a wrong filter and writes garbage over a day's swipes. It succeeds, nobody notices until morning. With plain files, that data is overwritten and gone. Recovery means a backup restore, if one exists, losing everything written since. But nothing here was overwritten. Yesterday's snapshot is intact, pointing at data files that still exist, because nothing is ever removed. Rolling back is moving the catalog pointer to the previous snapshot. It's the same conditional swap as any other commit, aimed backwards. The bad version isn't surgically undone, it stops being current. 5 snapshot icons, the 5th stamped bad job in red, an arrow labeled rollback pulls the catalog pointer from snapshot 5 back to 4. 2. You can query the past. Same fact again. Every previous snapshot is a complete, consistent picture of the table, and they all still exist. So you can ask what the table looked like last Tuesday and get an exact answer. A model trained then can be reproduced against the data as it actually was, not a table rewritten 100 times since. Auditing stops being archaeology. 3. You can change how the table is partitioned. With folder-based partitioning, the scheme is baked into the directory structure, so changing it means rewriting the table's entire history into a new layout. The choice you make before the first row is written is one you're stuck with, made at the moment you know least about how the table will be queried. Iceberg records the partition scheme in metadata and tags each data file with the scheme it was written under. Because old files are never rewritten, they simply keep their old tag. Partition our swipes table by month, discover queries are nearly always single day, switch to day, new data uses the new scheme, 2 years of history keeps the old one, and a query spanning both gets both handled correctly. No rewrite, no migration, no downtime. A timeline of data files, earlier ones tagged spec1 month, later ones tagged spec2 day. One query arrow spans both, captioned both handled, nothing rewritten. Rollback, time travel, partition evolution. 3 features, 1 cause. Nothing is ever removed. One central box reading nothing is ever removed with 3 arrows fanning out to rollback, time travel, and partition evolution, captioned 1 fact, 3 features. Which brings the bill. A table that only accumulates will, left alone, accumulate forever. Streaming writes produce thousands of small files a day. Merge on read stacks delete files that every read must apply. Every snapshot pins its data files in storage, so 2 years of history means paying for every version of every file it references. And the metadata tree that made planning fast in Video 1 grows until planning slows. The exact problem Iceberg was built to solve, reached from the opposite direction. So, Iceberg tables need housekeeping, and it comes as real table operations rather than scripts you invent. Compaction rewrites many small files into fewer large ones, the small files problem, solved as a table operation. It commits atomically like any other write, so readers see the old files right up until they see the new ones. No downtime, no window where the table looks wrong. Expiring snapshots drops old versions past your retention window and deletes the data files they were the last to reference. This is what finally reclaims storage. The delete from the start of this video only frees space once the snapshots referencing those rows expire. Rewriting manifests reorganizes the metadata layer so planning stays fast as history accumulates. Removing Orphan files clears debris left by jobs that wrote files but never committed, like the losing writer from last video. 4 operations feeding a table icon: compact, small files into large; expire, reclaim storage; rewrite manifests, keep planning fast; remove orphans, clear debris; caption, scheduled, not remembered. And notice the knob Discrets in your hands. Expiry is what reclaims storage, and it's also what ends your ability to travel back. Keep 90 days of snapshots, and you can reproduce any day in the last quarter, and you pay for every file those snapshots reference. Keep 7, and your storage is lean, and your audit window is a week. The feature and the bill are the same setting. That's the trade, stated plainly, and it's yours to choose rather than something the system decides for you. Now, the honest part, because a survey that only lists wins is a sales pitch. You may not need this. If your table is append-only, nobody deletes from it, the schema is stable, one job writes it, and it's small enough that listing files isn't a problem, plain Parquet and folders is completely fine and simpler and cheaper to run. Iceberg earns its keep when you have deletes, concurrent writers, evolving schemas, tables too large to list comfortably, or a regulatory reason to prove what the data looked like on a given day. Adopt it for a reason you can name. And it isn't the only answer. Delta Lake and Apache Hudi solved the same problem, giving a pile of file as a real table definition, with different designs and different trade-offs. Iceberg's particular bet was a fully open format with the catalog as the only coordination point, which is why it ended up supported by so many engines. Nothing is ever removed. Arrow, rollback, time travel, partition evolution. Arrow, and a maintenance bill. Arrow, retention is the dial. That's the whole thing across 3 videos. A table stops being a folder you hope is in a good state and becomes an explicit version description of what belongs, your data still in open files you own, readable by anything, and walker away from.